Hi. I've tried to share my screen.
Perfect.
Do I have audio?
Yes, perfect.
We can hear and we can see your slides.
Okay, that's good. I write sometimes things on my blog, and also about FORTH and how I started with FORTH. It's not really a FORTH blog, but Peter asked me if I can tell something about it. These are the topics that I want to tell about. Where I live. Peter also asked the last time, where do you live? My first computer and FORTH, using FORTH. That is my first post that I made about FORTH. And then I want to tell something about Create DOS. That's something, I'm explaining that because I also hope there are a lot of beginners that do not use it yet or do not really know how to use it. And then more about defining words to control hardware in FORTH. And I want to encourage playing with FORTH. Where I live, this is a picture of the environment where I live. I first thought putting a photo, but then I decided to put a video. Small. I hope you can see this. This is an incredible engine, and without that, I couldn't live where I live. It pumps up water. There are actually 2 levels, 5 meter and 6 meter high it can pump. It's one of the most biggest engines in the world. And I only show a very short video of it. Because where I live is below the bottom of the sea. All the land you see here was formerly water, that yellow part, and that's where I live now. This is in the Netherlands. I live now in one of the lowest parts in Almere, but I actually came from one of the highest parts, 322 meters in the south of Holland, and that was kind of different, and also different things that, because we live in an exciting time now. When I first started with computers, I could never believe that things would be like now, and hearing and talking to people. That's the 300 meters. It's not actually the highest point in the Netherlands. There's a higher point, but that is one of the colonies in Netherlands. And this is my blog post if you want to read it. And I started FORTH using an ELF2 computer. It has an 1802 processor. This is the short diagram of how the processor works. It has 16 registers, and those registers can be assigned to be the program counter or stack pointer or all that kind of things, and that's all controlled by registers. And that when I started, there was not much software available. So I was happy to receive a magazine with things written in it, short assembler routines. The memory was also very small, but there was also a graphic output. And there was also a FORTH version came out for the 1802 CPU. Only the problem is I built a small computer and I didn't have a real terminal connected to it. The computer had a memory that could be shown with a graphical chip, but not the really displaying, not an RS-232 terminal. I didn't have money for that, but there was a program that could create characters on it and acted as a terminal to actually have letters. So I did think I know the assembly code of that terminal program, and due to the good resources about FORTH and the wonderful book of Dr. Ting, who explained everything how the FIG-FORTH was working. I did think I could make this working to have graphical output and really use FORTH, because there was not much software available. This is also the processor, the 16 general purposes registers. They are almost the same, but there was a little problem. They were almost the same. They were not actually really the same, because this is how the graphics were made in memory. This is the graphic chip, and there was made an interrupt, and then this chip provided the video by displaying white or black on the screen. And you need to have an interrupt routine who did things like repeating the same line over and over again to make use of the video and to make higher characters. And the 16 registers that were inside, this is a list of the software that was available, the 16 registers that were available. In FORTH, in the FORTH implementation, they were already assigned to things, but also the video graphic routine used those routines. So one of the registers, register 2, is the return stack pointer in FORTH, but it also was used extensively in the graphic routine. So I need to manually change all the code, and in that time I could not use a computer to do that. I had to do is all hexadecimal, write things out, print things out, and also change other registers that contained constants that were used. And after a lot of rewriting, I was able to match the FORTH system with that graphical system. So I had a really working FORTH computer. And that was also a very big step in improving what I could do with the system, because in FORTH I could use an assembler that was written for the 1802 processor and write other programs, and also do little experiments by trying to control hardware and other kind of things. One of the nicest thing in FORTH, what I like much, is the build DOS, or what later became a create DOS function. And I hope there are also a lot of beginners who perhaps don't really know how that works. So I will explain it a very little bit as an introduction. When you use it in a column definition, you can create a word CCC and then build, and then every time the word CCC is executed, build defines a new word, that's in that part is defined how the things are really stored in the memory, and the DOS part contains the code when the words that you have defined with CCC, it gets a link to the part of the build, and there is included what you can do with it. This is the definition how it's in the FIG-FORTH manual. And as a little example, when you normally define a word, you say column, my first word, dub, 2 plus dots, point, comma, and then you have something defined. Let's say we make, you want to make something like a variable. You can say 15 variable, my first variable, and variable defines the word, my first variable, and it contains the value 15. To make your own defining variable, for example, to create a variable, I create gvar. You say colon gvar create, comma, does, and then close the command. And then when you say 12 gvar, my second variable, gvar is executed. The create path picks up the second var, puts that in the dictionary. The comma takes the first number from the stack, puts it in memory, and that is the defining part. And when you execute it, you get a pointer to that value 12. Another example, when you create a constant, my first constant, say you want to make something act like a constant, you can say my first constant is that variable and fetch that value. But that's a very strange way of creating a constant. You can make it more real by saying g constant create, comma, does, and in the does part you put the fetch part that picks up the value what you first stored in your dictionary. That only works for constant because you don't have the pointer to the memory, so you can't change it anymore. So that's a constant. And so the does part uses the addresses and fetches here the value. I think that this was a little bit boring for all the FORTH people who already know it, but you can use this concept to create your own defining words. And that is one of the greatest things I think there is in FORTH. For example, create a double-sized variable. You can say something like that also have initialized values, for example, 0. You can say gvar create 0, 0, and then does. And that way you can create new things. But there are also other things possible. You can also, before the create part, you can also put words. And you can use that, for example, to create some hardware. These are very old examples. And say you have some bits to control some device. And then a light in the children's room, a light in the living room, another light B, and a light in the bedroom. And say you want to create something to control that hardware, you can say, it would be nice if I could say something like 1, that is 1 is the first bit is high, is for defining the light in the children's room. 2, and that's just the second, or in binary you can say, a second bit for controlling the light in the living room, and so on. You can do that by making something like a defining word light, creates, and then store that value, and then in the does part, something to control that hardware. So this is a way you can control, you can use FORTH to create things to control your hardware. Perhaps you also want to think, how would I want to talk to FORTH? And then you could say something like off light living. That means I want to turn off the light in the living room, or on light bedroom to turn on the light in the bedroom, or whatever you want. So then when you know that, you're going to think, how do you need to implement the does part? When the does part, when the light living is executed, you can think, let's the on, off, or toggle, or test, or whatever word put a constant on the stack. So the first thing after the does part, what you need to do is to swap that values. Then you know what you want to do. You want to turn it on, off, toggle, or test. That's then on the top of the stack. And then you can use some kind of case statement to say what you want to do with that light to determine the action. Test in this case is to check if the light is on, or toggle if switch it on when it's off, or vice versa. So it's very powerful to think, how do I want to give a command to my FORTH system, and then you can use the code to implement that. So you can think, what kind of syntax do you want to control that? If you have multiple lights that you want to turn off, you can say you need to, as the word that is executed, the light living or light children's room, eats the first value of the stack. When you want to turn off 4 devices, you need to say off, 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 and then that kind of things, or you need to say off light living. And then you can think, perhaps that's complicated and I don't want that. I only want to say off and then the devices where I want to control. When you know that, you can think, how could I implement that? There are different ways to do that. You can create somewhere a variable that contains that first on, off, toggle, or test, and use that in the does part to know what you are going to do, and then you can reuse it in different words. Or you can say, I don't eat the value from the top of the stack, so then the action stays there, and you only say off. You can say off, and then the devices that you want to control. Another thing you can think is, I want to tell it quite a different way. Perhaps I want to make one word that does everything. I want to say a word, and I did put underscores between it, saying light living off, or light living on, or light living toggle, or test. You can do that by creating a word colon light that does multiple things. You can say, for example, I want to create one word and put multiple create does things in that big word. You can say, I make first a word light off, was a create does part to turn it off, and so on. And then you can say, I make one big word that does that all in one time. By defining it, I need how to do that. Another thing that you can use, you can say, perhaps I only want to say bit 2 does that control. You can also create a special case of create. You can study your FORTH implementation, how the word create works in FORTH, and then you will see that the input from create comes from the terminal buffer or a pad or somewhere else, and you can store the location before creating it where it's pointing, and then you can make a new create that first stores the location, then it goes on creating that word, putting in the dictionary, etc. And after you put it in the dictionary, you add the part underscore of.
Jan, excuse me, a short interruption. Please, if you can shorten, because we are with very short on time.
I will shorten as fast as possible. You can change the defining word by removing, by adding something in the create part, and move that things back, do that things again and again. After that, for that you need to study your FORTH. You can do other, perhaps you want to define other ways of controls that you can also add later on in your system. And I want to encourage you to all play with FORTH and use it and think, how do you want to talk to FORTH, and how can you use create does or other ways to make the syntax the way, act the way you like. Thank you.
Excellent. Thank you very much, Jan.
I need to find my